Yeah, excited to be here. Neil and I were actually just down in the Richmond area last week, and hoping to get in with a couple of these other RBA data and tech events as well. So hopefully we're not strangers to people who are in the Richmond area, and hopefully we get to see some of you guys more in person. We're lucky enough to meet Sam and Chase, a couple of guys who apparently was a previous presenter for the meetup. So yeah, excited to be doing this. And yeah, without further ado, I'll kind of get into it here. Like Sam mentioned, my name is Brendan Collins. I work here in the Mid-Atlantic area for Starburst Data, which is an enterprise version of Presto, formerly Presto, now Trino. Yeah, Neil and I are fortunate to work with a number of large Mid-Atlantic customers: Lockheed Martin, FINRA, ComScore, a couple of people that have some big data challenges, and we've been fortunate to dive in with them. Today, I'm going to talk about Iceberg, which is an interesting new table format developed at Netflix to replace some older table formats. I hope as we kind of go through this, when we come out the other side, I'm going to go through a couple slides, give you guys kind of a little bit of a background of where Iceberg came from, kind of what makes it interesting, what makes it different. And then I'll do a short kind of demonstration and show you guys a little bit of what Iceberg kind of looks like on the actual like tech side, physical tech side. So I think as Sam and I were talking about this before, a bunch of people came in. Feel free to drop questions in the chat. I'm not going to actively monitor the chat, but but Sam and other guys, if you guys don't mind, alerting me to questions, that would be great. And then also anybody that is interested in opening up a question, feel free to jump in as well. I think Sam and I got about a half hour of discussion, and then 5 or so minutes of kind of walking through stuff, and so happy to have any extra discussion. We should have plenty of time. So kind of getting into where Iceberg came from, we have to kind of go one step back to kind of think about what some of the traditional table formats were that were out there. And for a long period of time in the database world and the querying world, you were doing a lot of things in Hive, and Hive was kind of that technology that was built on top of Hadoop to be a SQL layer for data analysis. But as anybody who is familiar with Hive or had to do a bunch of things in Hive QL, or even if you came from like the MapR world over to Hive or things like that, there were some very clear limitations that evolved with Hive. One of the big ones was kind of this file relationship to bucketing. And so like when you would, bucket it a certain way, you had very little flexibility kind of on how you would come out of that. You always had some weird kind of aspects with ACID transactional capabilities where, you potentially could have somebody who's running a query actually locking some of your tables so that another application or another query that was attempting to query at the same time, was then either blocked from actually reading that, or it might get some kind of a dirty read because an actual transaction was occurring at the time that it was trying to read. You had weird kind of separation between Hive metastores and the actual data capability itself, where you had kind of this, rigid, costly computation that had to happen between the two. Everything you built up inside your metastore, and then kind of where you were actually laying your files. You had rigid partitioning. So like anybody who was, really, is really used to like how frequently customers were building partitions, say, based on month or week or even day for larger organizations. and you were pretty stuck with whatever partitioning method that you laid down. Once you laid down a particular partitioning style, you were pretty much stuck with that. And while you could make changes, which I'll kind of talk about in the next slide here, you were frequently doing a lot of redundant work when you were changing your partitioning scheme, whether that meant that you were adding a significant number, you were copying a bunch of your data, or you were basically making a redundant table that was over the same data but now had new partitioning. There was just a lot of kind of weird challenges around inflexibility with your partitioning. And you could never really do any real schema evolution. So as soon as you laid down a table, if you needed to add more columns or you needed to make some changes to columns, your schema evolution was pretty locked, right? So while Hive, and kind of my second bullet point here, somebody had to start somewhere with creating relational tables and creating a querying layer for big data sets. And so Hive was kind of that first layer that was created. And one thing that people who are familiar with Hive probably remember is there was kind of like weird, or still are, some kind of weird spec issues where like you didn't really have any standards around Hive. So like if you're using certain versions, then certain things didn't carry over to other versions. So again, like there was a couple different versions of Hive that kind of cropped up. But in general, right, Hive was kind of critical for sort of this first evolution of SQL querying. Whether that was whether we haven't actually made the full changes that we need to make there or not, I think Hive was kind of like the first kind of ground floor of where we needed to go. Let me propose kind of a scenario here, though, which is kind of a common problem when you're dealing with Hive. So I currently partition all of my incoming data by month. Maybe I have a supply chain type of use case where we have a bunch of transactional data that comes in, and we're currently creating partitions for January, February, March, and we have a certain block of files potentially that lock in for each of those partitions, right? Like, we take a group of transaction, we compact those into an ORC or a Parquet file, and we've, now got, 30 files that encompass, say 15 gigs of data that, work for the month of we'll say October, right? And now say that something happens like, a pandemic, or you have a large event that occurs, a bunch of stock market transactions happen, or, something that changes the way that my data is created. Well, now that you have a unique amount of data growth that could potentially spike, right? Maybe you have, like I said here, a new product release, could even do it, especially as we're talking about a supply chain use case here. So the Hive move is that you basically create a new table and would now partition by week or by day, right? And frequently when a user was querying, you now also had to let all your users know that you were changing your partitioning scheme. So you also had to have users who were querying that were aware of how you'd partitioned your data, one for performance, two for actual, understanding where data was actually going to be located. And under this scenario, I now have I basically have two tables that are the same data, one partitioned by month, and another that's partitioned by week or by day. And that now opens a number of challenges where I've either had to alert a bunch of my users that, hey, we have two tables that are basically the same thing. You should either not use the old table or use all of the old table prior to, September of 2021, and everything after this is going to be partitioned by week. But you guys can see how, and for many of you guys here on the call who've maybe, been data engineers, you can, you've probably dealt with like what a hassle this situation becomes, that, you've now kind of, at some point in time, some arbitrary point in time based on an event, have had to change your partitioning scheme. So that's where we had Apache Iceberg that got created. It got created at Netflix. One of the major reasons for that, as you guys can start to imagine, with a lot of the challenges around Iceberg, or excuse me, around Netflix, was things like I just mentioned, where you had major data spikes based on a new show was released, based on being able to open in a new part of the world. One of the big things that Netflix deals with quite a bit is rights management. So while Netflix may have the ability to show Marvel movies in Mexico, they can't show Marvel movies in the United States. So imagine like on one day when, they're suddenly allowed to start showing Marvel movies in the United States, they're able to advertise that accordingly. You can get, huge spikes of user interaction that didn't exist even hours before that, right? And so one of the things that Netflix was, wanted to be able to do is, one, create a table format that would allow for more flexible partitioning. So that's number one. And we'll kind of get into that in a minute. Apache Iceberg, as I have on kind of my first bullet point over here, it's a table format. It's not a file format. So when you're thinking about Parquet or ORC files, Avro, things like that, you could still use those files. You are merely putting a Iceberg table over top of those files. So for anybody who's kind of familiar with like some, as we start to get into this, you may see some similarities to things like Delta Lake, or even like Hive acid tables. And yes, there are some similarities, but like for Hive acid tables, you're very locked into ORC files. For Delta Lake, you're very locked into Parquet files. Apache Iceberg is not like that. It's a table format that can sit on top of multiple different types of file types. So again, that's one of the flexibilities of leveraging Iceberg. Another one is evolving schemas. So the ability to add to your schema on the fly. So potentially adding columns, right? Like on the fly, while they're operating. One of the things that Netflix dealt with quite a bit early on was this need for being more user focused. And I'll kind of talk about this a little bit later in the presentation, but one of the things that Netflix dealt with really early on was being more user focused. While Hive tends to be more organizationally focused for a business, Apache Iceberg can actually be more user focused on the tables, where essentially you could start to group and bucket things by a user. So Netflix keeps, a lot of track of what you've watched, how long you sat on something, et cetera, et cetera. And you can imagine that all of those data points have to get filed into tables. And so instead of them constantly needing to create new tables for new shows that they release, or new shows that certain users start to watch, again, like I mentioned, you have this concept of like different availabilities in different areas, right? So being able to add columns on the fly to specific areas to then be able to keep track of all that, those are the types of challenges that they built Iceberg to solve. Concept of time travel. Yeah, I had a little joke in here around whether you could actually time travel with Iceberg. No, not necessarily in that way, but you do have this concept of screenshots over time in Apache Iceberg. So I could potentially roll back to previous screenshots of my data, and the Apache Iceberg table will be able to tell me what that table looked like at that snapshot point in time, as opposed to also being able to look at it where I am in the future. So there is sort of the concept of quote unquote time travel, and I'll kind of get into what that looks like architecturally here in a minute, but they do have kind of the concept of time travel inside of Iceberg, which is where I kind of make some of the comparisons to Delta Lake as well. And then kind of the last piece here is it addresses this serializable isolation. So it addresses the ability to have consistency between metadata file state, which is kind of a long-winded way of saying that means that you can do like multiple ACID transactions on the same types of file sets, right? And you can have multiple different types of platforms that are connecting into things at the same time, right? And then the big piece, the reason why it's actually kind of called Iceberg, being that, you know, you're seeing a little piece and a user's seeing a little piece of things, but there's a whole bunch happening under the hood, is that Iceberg was built for like petabyte level table sets, right? So really, really massive data sets. And again, if you think about the types of challenges that Netflix was dealing with, like huge data sets, right? So going in a little deeper of like what you're actually going to have happen on a Iceberg kind of table, table architecture here. I mentioned the snapshots. So you have like a snapshot. In this case, we have snapshot 0 and we have snapshot 1, right? In our example here. And you can have umpteen snapshots, right? Like over the course of your Iceberg, life cycle. But for our purposes, we're just going to work with 2 snapshots here. And every snapshot basically has this manifest list file, which is an Avro file that basically you can open it and look at the JSON of it and, see what all is basically in there. But basically your manifest list file then points to these manifests. These manifests are then actually pointed at real data files underneath. So one of the big things that people who are familiar with Hive know is that Hive was kind of managed at the folder level, while Apache Iceberg is actually managed at the file level. So it gives them more flexibility around being able to point at which data sources which data exists at points in time or in certain locations, right? So it allows more flexibility when querying, right? That a query will come in that's for a snapshot 0. The manifest list will point exactly to the 2 manifests or the 3 manifests or the 1,000 manifests that apply for that query. And then those manifests will point you at the underlying files that need to be queried during that query, right? And those manifest files are actually critical to the performance scale that Iceberg is achieving, right? Because those manifests are, holding so much metadata about what's actually in those underlying files that's kind of how you achieve that petabyte scale, but really, really good performance at that scale is leveraging this architecture that they have here. So like I mentioned before, in kind of the old Hive world where you had to have users aware of your partitioning situation. So like this is kind of the example that we had before, right? Where you may have previously had a situation where you are partitioning a bunch of things by month, and you had a world where now your users, when launching a query, had to be aware of exactly what your partitioning scheme looked like on the underneath. While in the Iceberg world, you could actually make that switch, right, exactly on the same table, within line, basically. So your partitioning would go from your on the previous slide here. Let me see if I can go back real quick. Let me go back. On your previous slide here, your data files could actually be, your manifest could actually be pointed by month. And then in that same table, you could start having data files that are now partitioned by date in line, and your end user will never actually have to be aware that that's the case. And so the same queries that they're potentially running will never have to be aware of the partitioning scheme underneath. That has been completely abstracted from the user. Like I mentioned, if you think about the idea of an iceberg, that there's a whole bunch of stuff under the water and there's a little bit up top. The user doesn't need to be aware of all of what's happening on the underneath. You've really abstracted all of that complexity from them. And so that's, as I mentioned before, at Netflix, that's one of the huge things that they needed in a table format, was this ability to constantly add flexibility with their partitioning scheme and be able to make that so that users, analysts who are querying this, could make those changes on the fly, right, without needing to know anything about what that looks like. So let me give a brief example of kind of what that looks like. And I may have to relog into a couple things, but we'll see how it goes. So I am, as a representative of Starburst, I'm using our Starburst query engine to connect into an Iceberg table, an Iceberg data store that we have inside our demo cluster. So this cluster is sitting on AWS. You can see all of the different data sources that we're connected into here on the left. Your AZ data sources are actually located in Azure. Your GCP data sources are actually located in GCP. And our Iceberg table here is located in S3 AWS. I'm actually going to go to it in just a second. We have some fake financial data here inside our demo cluster. And we have some tables that are part of this fake financial data. So like we have like fake auto loan payments, fake credit card payments. And initially, to start with, let me pull this piece out. Initially, to start with, I ran basically just a sample federated query where I joined data from a MySQL database and a Postgres database. So I run this particular query. I now have potentially like a group, a cross section of data that I want, where I've joined based on a customer key. And again, bear in mind, this is all just kind of fake data that we use for demonstrations. But then what I wanted to do is I actually wanted to turn this into an Iceberg table. So what I had pasted in there is I did a create table statement on our Iceberg example meetup table here. And let's see, for the purposes of our example, let's maybe just run again and see if we can just do a second table creation here. So we'll do a Iceberg burst bank meetup table 2. And so let me refresh here and see if when we go down into our tables, we have a Iceberg meetup table 2, right? And so we've now created some, we took some data from 2 other data sources. We pointed it at our Iceberg connector, and we basically ran a simple create table as statement to where we have our Iceberg connector plugged into. And so we now have a table that we could probably query. Let's see, what is that? Iceberg table 2. Let's do just a select star from, blow away what else we've got here. Get rid of our as, go ahead and run a select star. Okay, so we got our same data back, right? Now, let's look at what actually happened in our AWS object storage. So let me come back here. I may end up having to relog into here, but we'll see if it's okay with that. Okay, no, I did not need to relog in. So we can see here that we have in our Iceberg, our Iceberg connector is pointed at this object storage here in AWS. You can see some of our other tables here as well. But let me go to the actual meetup table 2 that we created. And you can see that 2 folders are created. You'll notice when I ran my create table statement, I didn't specify anything about what I wanted created, right? Iceberg handled that piece for me. So you'll notice that two folders were created when I made that create table statement. One is our metadata folder, which contains our snapshot, right? Which is actually going to be our metadata JSON here is our snapshot. And then it contains 2 Avro files, which are actually the beginning of our manifest lists here, right? So these 2 Avro files are actually going to start containing our metadata for our manifest list. And you'll see right now, these are relatively small in size. It wasn't a ton of data. So, you'll see that those are actually not too bad. And then you come over here to the data, which is actually our ORC file that we created here. Again, not particularly huge. It was 2,000 rows or something like that. And it came out for, 22 kilobytes here. But this is where our actual, ORC file lives, right? So you can see, as you can start to expand this out, right, you'll have your ORC or Parquet files that will continue to expand out. And then your metadata will actually be bucketed in its own, metadata file or metadata file path, right? And that's where you'll see like kind of those two, those architecture pieces that we mentioned on the previous slides kind of come into play there. Let me. So what are a lot of kind of the primary use cases that people look at Iceberg a lot for? So one of the big ones is GDPR. As you can imagine, like Netflix operating all over the world and a number of organizations operating all over the world, a lot of the challenges around GDPR regulation for people who are not familiar with it is that you have, quote, the right to be forgotten by a company in Europe specifically, where data that's either older than 10 years, a company has to remove everything but, I want to say, like your name and a contact record. So like they can keep your name and an email address for anything older than like 10 years, but they have to start removing data about, what you bought, how much you paid for it, your credit card information, like all of that stuff has to start going away after 10 years. And then at any point in time, somebody can opt into GDPR, rights where they basically say, hey, I don't want you to be storing any of this information. So for things like Netflix that operate in Europe, one of the big ones that Neil and I have worked with is Marriott. If you think about people that have to deal with like hotel stays, and you have users that are in the United States who, maybe have totally different regulations where you could keep a hotel stay in the United States for 25 years, unless you're in California, which then has its own California data protection laws. And then, they also could be staying in Europe when they're on vacation or business travel. And same for Netflix, because you can go use your Netflix account in the UK or Germany. And so if you start to think about like what that means for like how as an organization you want to be keeping track of what users are doing, but then also be able to adhere to regulatory policies like GDPR, the ability to make CRUD operation changes and ACID transactions on the fly and be able to leverage those at the file level where you can make deletions or changes at the file level, insert, update, delete statements at the file level, and do so performantly when you start to get up to petabyte scale. You guys can see how like that snowball starts to roll down the hill, that when you were dealing with some of those old Hive challenges, like that starts to become unbelievably unwieldy and leads to a lot of mess. Iceberg is what Netflix kind of, created to handle a lot of those challenges. And then the other piece of that is recommendation engines. So as you're all aware, just about any shopping or any service that you use online loves to recommend to you what else you should do or what other users who've done the exact same thing are doing as well. And Netflix was no different, where Netflix, when you're watching, whatever, says, this is recommended for you. And, they, whether it's something that's popular, whether it's something that matches your, interests and, may keep you there longer and you go down the fun rabbit hole that is, watching Netflix shows or what have you. The challenge there was that those are all driven, as probably many people on the call know, by machine learning models that are algorithms that are kind of based on, data from the past. But to make those work, you have to do those, very fast on the fly so that like, when that page first loads, people that looked at this, people that bought this pair of shoes also bought, this pair of socks. That has to load very quickly, right? You don't want that, the person's already made the purchase if it takes, a minute to create and load that page. And ditto with the Netflix shows as well. Someone pops in there and doesn't see anything that they like and they close the app, you've lost them, right? So those recommendation engines have to operate very, very quickly. Those algorithms have to operate very, very quickly. And so this idea of these tables being more user focused, where you could do bucketing based on users, starts to come into play very, very quickly, where as you start to have these large scale tables that could then operate very, very quickly, you can then have situations where recommendation engine runs based specifically on a user or group of users, makes the return back very quickly, and recommends the specific movie, TV show, pair of socks, whatever it may be here. Those today are some of like the primary use cases for Iceberg. There are definitely a lot more. Regulations are obviously a big one, and obviously Iceberg's still very new. It's only in its version 1 of its spec. So again, the title of the talk was kind of like Iceberg dead ahead. Like, we've seen a lot of companies start to adopt this, so I'm sure the use cases will continue to expand as people see more and more value out of it. But these are some of the big ones, especially when you're talking about like at scale usage. So kind of like the so what, right? Like, I've told you. Yeah, go ahead.
I know where you're getting to, and we had one question come through the chat. I don't know, Sam, if you are okay with me reading this, I'm happy to do so.
Go for it.
If you are a current Delta Lake user, is there a unique advantage to switching to Iceberg, or are they feature equivalent other than being tied to Parquet only with Delta?
Yeah, that's a good question. So one thing so some of the differences between Delta Lake and Apache Iceberg, Delta Lake today is driven primarily by Databricks as an organization. They're kind of the arbiter of that open source project. Apache Iceberg today is still very open source. That doesn't mean that a enterprise company is not going to start building around them. I think that there's potentially a couple out there that have started to crop up, but are very early days as far as that's concerned. You mentioned the file format thing, where Iceberg gives you more flexibility to leverage different types of file formats, Parquet, ORC, Avro. Delta Lake is also very engine specific. So today, primarily only Spark can do most of your updates on Delta Lake, while Iceberg, really any engine today has the ability to make updates to Iceberg. So potentially, if you want to have some flexibility in how you handle that, you can, in what types of engines people are accessing your tables with. That's one like major difference between the two. And then kind of like the last piece is some of the kind of goes back to the who's driving, is kind of its open source flexibility, where you do have today that Databricks is holding Delta Lake performance gated behind some licensing with Spark and the Databricks product, while Apache Iceberg today, could change obviously, is not being gated by any enterprise product. It is still open source completely. So there are a couple differences in that sense, in terms of like, functional differences, in terms of like features. They're very, very similar. And then there is the flexibility around the actual like files. ORC, Parquet, and Avro is available in Iceberg. Yeah, it's a good question though. I mean, there's definitely a lot of, like Hive acid tables, Delta Lake, and Apache Iceberg, a lot of very similar functionality for sure. So Yeah, no, that's a good question. So we went through a bunch of stuff with and so that question kind of coming into this piece. We went through a bunch of stuff as to, what's kind of this, what's the so what of why I would be interested in using Apache Iceberg. Snapshot isolation for transactions is a big one. So like all of your rights are atomic, basically. You have the ability for concurrent rights, on Apache Iceberg. And so you can have read and write, you can have reading and writing concurrently that don't interact with each other. So you don't have to worry about some of those Hive challenges I mentioned early on, where you kind of had like, potentially dirty reads or lockouts or things like that. That's due to that snapshot isolation that we mentioned, right? So you can always roll back and look at older snapshots and see changes that were made. And so like, a new write potentially can create a new snapshot, and then you can just run like a compaction to clear out old snapshots and things like that. So you don't have to be worried about, having millions and millions of snapshots. You can kind of get those and millions and millions of snapshots, and then kind of combine those all into, a handful of snapshots that maybe you want to do hourly, weekly, daily, whatever really makes sense. Because of that, like, the list of files being written, the manifest list, and then the manifests themselves architecture, you can have significantly faster planning and execution. We probably need somebody who actually is from like the Netflix Apache Iceberg team to actually talk about what all went into that architecture, like what's actually happening at that level. But the way that the metadata being tied to those manifest lists and then the manifests themselves, as it relates to the underlying files, allow for significantly faster, planning and execution. You're able to, because of that, expose more actual logic to your table, and not needing users to understand things like physical partitions. Like we talked about that a little bit earlier on, but like being able to really keep a lot of that away from your end users, so that you can basically just create on the fly, a table format that you can create on the fly schemas, evolve your schemas that then map to business logic needs and business needs, that your users don't need to be aware of how you've like had to, change your tables or add tables or create new tables over the same data, that kind of thing. All of that kind of gets abstracted with the with Iceberg. You have the ability to leverage some event listeners. So Iceberg has services, has a group of libraries that are allow you to have other service notified when events occur inside of Iceberg. So you can have a lot of potential future capability around things like potentially kicking off Lambda jobs, or notifying other databases or other data sources, or even front end systems about what's happened on a specific table, or certain, again, events that occur on your table that you then want to be alerted to elsewhere in kind of your data pipeline, or upstream. There's a lot of that's still very new functionality, but there's a lot of kind of interesting implications of what you could start to do there. And then because of that read write capability, you can make smaller updates. So again, like when you're talking about those like GDPR use cases where you want to update a record because somebody opted out or opted in, if you had 1,000 people that visited a hotel on a certain day, and you had 2 of those people wanted to opt out due to GDPR, you're not having to update or change entire tables. You're able to make updates that then gets right down to the actual file of where that data is located. You're making that update. And again, like a snapshot is then created as to what exactly occurred. And then kind of lastly, like all of your engines are seeing changes immediately. So because your table's contents are being defined on like your right side, all new readers are immediately pointed at the new manifest list that gets written. So as soon as a writer makes a change to a table, all the new queries can immediately start running against this new data that's been written. So, that's a huge difference from the way that, like we talked about with like the Hive ACID transaction, locking of tables. I see in the chat, Jason, it looks like you were interested in talking a little bit about the manifest list architecture. That would be awesome. I did see the question around Starburst. I'm happy to kind of wrap with that at the end, talk a little bit about what we're doing there. But Jason, while we're here on the topic, I would love for you to chime in about that manifest list architecture.
Yeah, sure. So thanks, Brendan. I'm Jason. I apologize for don't mean to be lurking in the data engineering meetup, but it showed up in my world. And so I've been at Netflix for the past 8 years or so. I'm one of these people I recently left, joining Ryan, who was the creator of Iceberg, and we are starting a sort of a commercial venture around that. And so I'm one of the founders there. So I'm very interested to hear what people are doing with Iceberg and the problems people might be facing. But in terms of just the architectural choice for manifest, and it also speaks to, I think, one of the deltas between, no pun intended, Iceberg and like a Delta Lake that somebody else also asked about, is really avoiding directory listings. So Iceberg was designed for cloud object storage, like very much from the ground up, because at Netflix, very early on, we did all of our data warehousing on S3. And so systems that were designed for Hadoop and HDFS, there were some real struggles in trying to move that into S3. And one of those is the performance of like doing directory listing. And so the manifest file is one big thing it does is avoids any sort of directory listings. Everything is key lookup, right? All the files are key lookups, which object stores are really fast at and really good at. So it makes the query planning a lot faster. And then the other thing that they do is they hold a bunch of metadata. So if folks are familiar with how Parquet operates, where you've got file level metadata that allows you to do predicate pushdown, filter, skip reading files based on query predicates. Iceberg manifest files and metadata files do that, basically allow you to avoid having to list the file at all. So there's metadata in there that says like, hey, these files contain this range of data. And if your query doesn't deal with that data, then we don't even have to open the file whatsoever. So it just adds to performance quite a bit, especially for large tables. The example that Ryan Blue will always give here is we replaced a Splunk-like system at Netflix for doing very pinpoint sort of queries against log data, like system log data, leveraging this. And, it was incredibly performant, using a very small Trino cluster. It worked extremely well, and it was, high performant on large volume of data. So I don't know if that helps clarify a little bit.
Yeah, it did for me. That's awesome, Jason, to have you, someone who actually was part of the Iceberg project on the in the meetup. Kind of a 2-for-1 for Sam.
Cool.
Yeah, that's super cool. No, I'm happy to have you, critique anything I had here, and if there's anything else you think that we're kind of missing around Iceberg, I'm happy to have you kind of chime in on that as well before I pop over to do just a little bit about Trino. He gave us a little plug there that yes, Netflix is one of our big users of Trino. I know he doesn't work there anymore, but Netflix is one of the big users of Trino, which Starburst is an enterprise version of. But yeah, Jason, anything else on Iceberg before I just pop over there and give our 5-minute spiel on what we do?
No, I thought you did a great job, Brandon, of articulating a lot of the reasons why. So that was great. Thank you for that. And yeah, still a big Trino and Starburst fan for sure. So
Well, thank you. Yeah, so real quick, let me briefly talk a little bit about what we do here at Starburst. So Starburst actually is really quickly pull up an architecture diagram of just kind of what we do, just to make sure that it's clear for everybody. We are an engine, so very similar to Spark. What was kind of discussed, a little bit of what Jason was going into there was, we are a consumption engine. So the way that, Databricks is a consumption or an engine for Spark and Delta Lake, we are that for Trino, which Presto Trino was formerly Presto, now Trino, is an open source project that was actually created at Facebook. It was built to query large data lakes, primarily at Facebook, where they had, quite literally petabyte level. I think our founder, a couple of our founders who are CTOs here, who, Jason, you probably met one of them, David, I think actually came to the Netflix headquarters at one point to talk to the Iceberg team kind of about what would be needed to plug the open source Trino project into Iceberg. He's one of our CTOs. We kind of have three CTOs. It's a little bit of a ceremonial title here, but it's three guys who initially built Presto at Facebook, then called Presto, now is called Trino. And it was an engine that again, they sat on top of, I think they said at one point about 220 petabytes of data that was at Facebook. And if you think about this concept of needing to serve thousands of data analysts and needing to get them to have access to petabytes of data, hundreds of petabytes of data, the challenge to do that was one that was similar to the challenge that the Iceberg team faced at Netflix, in terms of, you have a challenge that the current technology that exists does not suit this need. And so basically they built this engine, which is essentially a compute engine, which is it's built with Java, and it's a incredibly fast SQL engine that basically handles really anything that can do a JDBC or ODBC connection on the front end, plugs into our engine, and then connects across a number of different data sources on the back end. Our wheelhouse is really ORC and Parquet files, but we do frequently see ourselves connecting into Teradata, Oracle, Postgres, MySQL, and then a number of things like your Mongos and Kafkas of the world are starting to really crop up as well. And we connect across all of those. So how we would fit in with Iceberg kind of goes back to what I had kind of in my little demo here. Iceberg we would see as a data source. Again, it's ORC and Parquet files or Avro files underneath, which are all fine for us. We can basically view those alongside our other data sources here, and we could run federated queries or singular queries directly to Iceberg tables. Today we have a good amount of functionality around the V1 of the Iceberg API. I know that, and Jason, you may be able to fill us in a little bit on this. I know that the V2 is coming or has come relatively soon, and Starburst is planning to have an Iceberg connector fully functional towards V2 latter end of this year, might be in January, but our goal is to be fully compliant with the V2 specs pretty shortly here as well. Jason, I don't know, what is V2 out? Or
yeah, so quickly, V2 has been fully adopted by the Iceberg community, and really the big level change there is row level operations. So Brendan, you articulated well. I think it's already a lot better to operate at a file level when you need to make changes like GDPR deletes or upserts, rather than dealing with whole partitions like we had to do in Hive tables, which is really painful. And the V2 of Iceberg really takes that to the next level and allows you to do row level operations. So if you're doing like a GDPR delete, for an account ID across, petabytes and petabytes of data, instead of having to rewrite the entire table, you can just write delete files. And you can either basically use a merge on read strategy so that when you select from that table, those deletes are removed, or you can do a copy on write strategy, right, which is updating the file in place when those deletes happen, and you can do a combination of the two things, which is really the power. Is like, if you need to do the writes very quickly or the deletes very quickly, you can do that, and you can come behind later and merge those changes in through some background processing while you're doing file compaction or some other table cleanup operation. So we're excited about V2. It's fully adopted by the community. We're excited to have engines like Trino and Starburst supporting it. We'll really make these kinds of use cases much less painful for data teams out there.
Very cool. So Sam, that was kind of what I had for presentationally, but obviously happy to, we've still got a little bit of time, happy to answer any questions, have any discussion. And yeah, like I said, awesome to have, I wish in other situations I could snap my fingers and have a creator of the project just show up when I mention it. But no, this was awesome to have Jason here as well. Might as well have people ask any questions that they have. So.
Yeah. Great presentation. I think it was done really well. I'm actually surprised we didn't get more questions throughout the presentation, but very, very cool and surprising and convenient that Jason happened to pop in. So, thanks for your time tonight, Jason and Brendan, of course.
Sure.
So there were a couple questions in the in like sort of the chat.
Yep.
It looks like Neil was able to kind of like knock out a handful of those. I'm not sure if you wanted to add anything to that, Brendan.
Yeah, let's see.
Keep me honest, Brendan. Don't let me put my foot in my mouth.
Okay, so I think picking up where we hadn't answered anything, Starburst has a concept of, does Starburst have a concept of a semantic layer? Yes. So that's kind of where, so we would be able to join with something like an Apache Ranger, which is a security tool that would allow you to create things like global security policies. We could also connect in with like an Atlas or things like a Calibra, or I'm forgetting one of the other data cataloging tools out there, Elation, which would allow you to then kind of unify not just your query engine, but also have this concept of security where you could do column and row level security, and then as well leveraging a data catalog in there. As well, we do connect into metastores. We generally are leveraging metastores that already exist, but we have in certain cases brought our own metastore as well. So we do kind of have all that. We can unify with all that. I mean, our bread and butter is a query engine, but we certainly for a number of customers are building what we call this semantic layer. And then let me see what else. Prasad, does Iceberg do row level update instead of file level? It sounds like from Jason, what you were just discussing, it sounds like that is now, that was one of the big capabilities that was brought into V2, was the ability to do row level, or row level updating. So yes, you can do that.
And just to clarify, the file is basically immutable, right? A snapshot for an Iceberg table is an immutable thing, and that's important because, again, cloud object stores and not having the eventual consistency and all those challenges, right? So once data is written, it's immutable. What the V2 does, it says you can make a change to a table, produce a new snapshot. You could just add like hey, this row has now been deleted from the table. So one small file that represents a very small change. And so your manifest list, from snapshot to snapshot, is this very small change that, oh, I have now this one additional file, which is a delete. And so it's a very quick operation, very light operation, which doesn't require rewriting the whole file. But at some point, if you want to sort of merge that in and collapse that back into the table and not have a sort of delete file hanging out there, that would constitute like its own update to the table and a new file. It basically a swap out of that file in the manifest. So it's not mutable in that sense, but perform it in another way.
Hey, Brendan, BG asked me, I think maybe by accident directly, because I don't know the answer to this, but can you talk about streaming use cases? I assume it is supported with Flink as the engine.
Yeah, Jason's right on with the thumbs up. Yeah, so we generally see that people would use something like Flink as an ingestion to get things into Iceberg. Yeah, Trino today is not really an ingestion engine, and probably doesn't really have a ton of plans to do a lot on the ingestion side in the future. But yes, something like Flink is a great ingestion engine to pipe data into an Iceberg. Jason, I don't know, is that where I think actually when I was doing some research for a Iceberg related thing that I had done earlier in the year, I think it was mentioned that at Netflix you guys were using Flink to do some ingestion into your Iceberg tables. So
yeah, I think most existing Iceberg customers are using Flink to stream data into tables if they're streaming data in. So that's got really great support. You can do really high throughput, like really high frequency commits into tables, and you, as you mentioned it in your talk, which was great, like that's immediately available to all the other engines. So yeah, you can be streaming data in from Flink and querying it from Trino, and it's all readily available. It's really nice.
Last one I'm seeing here, will there be a metastore exposed like Hive? Would Rights be able to trigger external events? So we did talk about, and I may leverage Jason here again to talk about what some of those event listener type things would be able to trigger external events. So you don't need a metastore with Iceberg because, as discussed, like the metadata is being stored in those manifest list files. With Starburst, we can use a metastore to save things like views in. But if you're talking specifically around Iceberg, you don't need to have a metastore that's like exposed with like a thrift service. I don't know for William, I don't know if that totally answers your.
Yeah, it kind of does. So just trying to figure out, I know I have an Iceberg table and that has a manifest list and all those things. How do I know that I have a collection of Iceberg tables? Would there be another answer for that?
Yeah, it's typically there's some sort of catalog that can be any number. There's a variety of implementations because the Iceberg specification doesn't implement anything particular there. So you can actually use a Hive catalog, or it's like a Hadoop catalog. You can use native ones in Spark or in like file system ones. That's one of the offerings, obviously, and on the commercial side of what we're building, it is a catalog type service around Iceberg. So yeah. I imagine, Brendan, in your example, that's probably like a Hive catalog that's storing all those tables you're creating.
Yeah, so for Starburst, we are using basically the architecture of our Hive or Delta catalog to create our Iceberg catalog as well, our Iceberg connector. So we are actually using kind of the bare bones of that to then, to organize multiple Iceberg tables under one umbrella. And I believe the architecture is almost identical to our Delta Lake connector, but you obviously could not do Delta table operations through your Iceberg connector and vice versa, but the architecture is very, very similar of how we did it on our side so that it functions for our query engine.
It's basically a listing of tables which contain the current pointer to the current snapshot.
Yep. Let's see, BG had a follow-up with Flink as an engine. Is there latency introduced or good enough for sub-second queries or processing? So you have kind of two, Flink obviously can write extremely fast and would be able to update your Iceberg tables quite quickly. But then you're saying good enough for sub-second queries or processing. So you would have to have an engine on the back end that's also actually able to do sub-second querying as well. So that would depend highly on that your question kind of contains two sides there. Flink would be able to be updating data quite quickly. Obviously, it would still kind of depend on how much you're needing to have updated at any given time, but Flink is built for quite a high volume of data. But then you would also need to have something like a Trino that would be able to actually query fast enough for that to make a difference. Because obviously you'd still be kind of bound by how quickly you could get that back out. So there's kind of two sides to that question, but that is a good question though.
Yeah,
Very
I'll just
cool.
add to that. The commits are pretty lightweight, and so they can be done at pretty high frequencies. There are some caveats there. You can get yourself into some bad situations, not because you can't do it. It's all relatively fast, but it's not great for analytical purposes. You have lots of small files. Data isn't well organized. You can't do a lot of pruning and things. So you could use it. It likely isn't the best fit if that's what you're, depending on your use case. The whole like Flink, Iceberg, Trino setup is probably not the right answer for sub-second stuff.
Yeah, you would want to run some compaction and snapshot pruning at times to kind of
yes,
get that a little nicer. Yeah.
Yeah. If you do that, you're just going to put a little more burden on yourself to do the compaction, and you can run into a bunch of like commit congestion. So it's not super recommended for that use case. Nothing prevents you technically.
That makes sense. Thank you.
Okay, cool. I think that pretty much wraps up our questions. So I think, I'm good to, conclude right here. I do have one sort of, well, first off, thanks, Brendan, of course, for presenting tonight. I think you did a great job. I love these deep, these sort of deep dive talks on these open source projects. I think we get a lot of really good engagement, as you've seen, pretty good questions. And, of course, thanks, Jason, for popping in. I would say this is probably our first sort of, founder of a project that's like come on one of our like deep dive talks. So it's really interesting to get your insight along with Brendan's presentation. And like at least halfway through, he was, presenting too. So that was I'm sure Brendan was surprised and probably happy to see this. So yeah, very,
Sure.
very interesting stuff. It'll be fun to tell the team tomorrow at stand up. So yeah, basically, as far as RVAD goes, next month, we're actually gonna have the Chief Data Officer of Virginia come and give a presentation, kind of a sort of a State of the Union talk, but for data. So state of the data sort of in Virginia. He's going to be focusing a lot on the platform he's built to kind of open source a lot of data sets around Virginia and integrate like a lot of different sort of disparate data sets together. A lot of focus on data governance stuff. He gave a talk actually exactly 2 years ago from November. So it's kind of our 2-year anniversary at the same time as well, because we will be exactly 2 years old as of next month. So yeah, we're pretty excited for that talk. But yeah, otherwise, I'm gonna go ahead and kill the recording right here, and this will be